had a few students ask about problem number 15 from the Q4 Day 12 homework assignment. So I'm going to go over it. Okay, so problem number 15, they give you this graph, and they tell you that this is the graph of f. The graph of a differentiable function f is shown above. If h of x equals the integral from 0 to x of f of t dt, which of the following is true? Okay, so you have 5 possibilities, and the 5 options here they all have one thing in common. They're asking, or they are relating h of x, h prime of x, and h double prime of x, or h of 6, h prime of 6, and h double prime of 6. And they're using inequality notation to see which one's bigger than the other, and so on. So one thing that should be a given here is that you should calculate h of 6, h prime of 6, and h double prime of 6. Okay, and here's the key. So using this key, I'm going to replace x with a 6. So now h of 6 equals the integral from 0 to 6 of f of t dt. So one thing you got to remember is that integral, one of the representations of integration is area. So one of the usefulness of the integral is that it represents area, and it's a lot easier to find the area when the shapes are nice and they're given by straight lines, by functions that are straight lines. We're pretty much asked, or the integral from 0 to 6 of f of t dt represents the area of this shape, which is curved. And we don't know a function, so we can't use the fundamental theorem of calculus to integrate this. So one thing that you should understand, though, is that from 0 to 6, the area happens to be on the negative side, below the x-axis. So that's what we have. Okay, so our integral from 0 to 6 of f of t dt is pretty much this negative area. So we don't know exactly what value it is, but we know that it's negative. Okay, it does get positive afterwards, but that's after x equals 6. That's not part of our integral, so I'm not going to worry about that. We just know that it's negative. Okay, so that's one of the things you should have considered. Now, another thing is h prime of 6. Before we do this, you have to understand or remind yourself of the fundamental theorem of calculus, part 1. So using the fundamental theorem of calculus, we can go ahead and take our key, h of x equals the integral from 0 to x of f of t dt, and calculate h prime of x equals f of x. Okay, so we can definitely go from this to this using the fundamental theorem of calculus. So h prime of 6 is pretty much the same as f of 6, and if you look at your graph, f of 6 is 0. So this is the point 6 comma 0. So when x equals 6, we get 0. Okay, so far we know that h of 6 is negative, h prime of 6 is 0, so far we know that h of 6 is less than h prime of 6. And now I'm going to look at the second derivative, and we can again keep going from this start here. We went from h of x to h prime of x to h double prime of x is just f prime of x. So using that, we know that h double prime of 6 equals f prime of 6. Now, what this is, f prime of 6 is the slope of the tangent line at x equals 6. Okay, so the slope of the tangent line when x equals 6. So I do not know what the exact value of the slope is, but I know that the tangent line at x equals 6 is something like that. And I do know that that's a positive slope, so it is positive, which tells me that this is positive, which then tells me that this h double prime of 6 should be greater than h prime of 6. So the answer is A.